Welcome to week 8 of Precalculus. Our topic, sigma notation. For the expected learning outcome, at the end of the lesson, the learner should be able to use the sigma notation to represent the series. The sigma notation is a shorthand for writing sums. We now introduce a special notation for writing sum of the terms of a sequence. This notation is called the sigma notation, also known as summation notation. It involves the use of the capital Greek letter for S, called sigma, which is denoted by the symbol. We will see the use of the symbol I, which is called the index of the summation. The index serves as dummy variable because it can be replaced by any other symbols. If f of I denotes some fractional expression involving variable I, then f of m plus f of m plus 1 plus f of m plus 2 plus and so on plus f of n can be compactly written in sigma notation, and we write it as the summation of f of I from I equals m to n, where m and n are integers with m less than or equal to n. F of I is a term of the summation, and the letter I is the index, m the lower bound, and n is the upper bound. The value of I starts at m and ends at n. Let's have some examples. Expand each summation and simplify if possible. Number 1. The summation of 2I from I equals 1 to 5. What we'll do is substitute first. So we have equals 2 times 1 plus 2 times 2 plus 2 times 3 plus 2 times 4 plus 2 times 5, since the value of I is from 1 up to 5. Next, simplify. 2 times 1 is 2, plus 2 times 2 is 4, plus 2 times 3 is 6, plus 2 times 4 is 8, plus 2 times 5 is 10, equals, we'll add 2 plus 4 plus 6 plus 8 plus 10 equals 30. So we have the summation of 2I from I equals 1 to 5 equals 30. Example number 2. The summation of 2 raised to I from I equals 0 to 5 equals, again substitute 0 up to 5 on the exponent, which is I. 2 raised to 0 plus 2 raised to 1 plus 2 raised to 2 plus 2 raised to 3 plus 2 raised to 4 plus 2 raised to 5 equals 2 raised to 0 is 1, because any number raised to 0 is equal to 1, plus 2 plus 2 squared is 2 times 2, that's 4, plus 2 cubed is 2 times 2 times 2, that is 8, plus 2 raised to 4, 2 times 2 times 2 times 2, that's 16, plus 2 raised to 5, 2 times 2 times 2 times 2 times 2, that is 32. Then we add 1 plus 2 plus 4 plus 8 plus 16 plus 32 equals 63. So we have the summation of 2 raised to I from I equals 0 to 5 equals 63. Let's have example number 3. The summation of the quantity of 2I plus 3 from I equals 2 to 4 equals, let's substitute, 2 times 2 plus 3 plus 2 times 3 plus 3 plus 2 times 4 plus 3. Take note that we will not start with 1 because I starts from 2 and ends at 4. So we have 2, 3, 4 in place of I. Equals, simplify. 2 times 2 is 4 plus 3, that's 7. 2 times 3 is 6 plus 3, that's 9. 2 times 4 plus 3 is 11. 7 plus 9 plus 11 equals 27. Therefore, the summation of 2I plus 3 from I equals 2 to 4 equals 27. Associated with sequence a sub 1, a sub 2, a sub 3 up to a sub n is the series. For the sequence 4, 8, 12, 16, 20, 24, the associated series is 4 plus 8 plus 12 plus 16 plus 20 plus 24. And we can actually write that using sigma notations. That will be the summation of 4I from I equals 1 to 6. For the next example, we have given 3 plus 6 plus 9 plus 12 plus 15. For the solution, the general term is a sub n equals 3n, since a sub 1 equals 3 times 1, a sub 2 equals 3 times 2, a sub 3 equals 3 times 3, a sub 4 equals 3 times 4, and a sub 5 equals 3 times 5. So we have 3 plus 6 plus 9 plus 12 plus 15 equals the summation of 3I from I equals 1 to 5. That will be all for this session. See you next meeting.